All right, before we get started in new material from Chapter 7, we're going to start with some review of some concepts that we learned way back in Chapter 3. So we're going to freshen up on those and build upon them as we move through Chapter 7. All right, and this is where the pre-algebra concepts start to get a little bit more challenging. All right, so make sure that you're working hard to seek understanding and asking questions along the way as you have them. These concepts will come up in all of your future math classes as you build upon these as you go. So back in chapter 3, we talked a lot about solving equations. We introduced you to the concept of variable um, and what it meant to solve. And we used inverse operations, right? Remember, when we solve, it means to isolate a variable on one side of the equation. So we get x equals some number, right? Like x equals 5. Um, we solve using inverse operations, meaning if I started with a problem like x plus 5 equals 10, right? To solve this, right, since it's equal, it's balanced on both sides. So some number plus 5 equals 10. Well, to solve that, right, we would subtract 5 from both sides, right, and that would cancel. That would leave me with x here. 10 minus 5 would equal 5, right? So we used inverse of addition, right? It was a number plus, so we subtracted from both sides. And we know that as long as we do it on both sides, it's still going to be equal. And then the same with multiplication and division. And remember both sides, right? Meaning that on an equal sign, right, we have this left side over here and this right side, and they're balanced, right? Meaning if I take away 5 from this side, it's not equal unless I do the same thing from the other. So we have to keep that equality by doing the same operations on both sides. Um, and then just a refresh of the words we use for addition, right? A lot of times it's sum, right? But you hear add, plus, total, increase, right? The plus symbol. For subtraction, a lot of times it's difference, but you can see the other words that are used. And then same with multiplication and division. All right, so I'm going to go through some of these review problems, and then you're going to do a quick check in Schoology just to make sure you're where you need to be with solving those equations before we start into 7-1 and build upon these concepts. Okay, now one thing I want to remind you of, the ones that you'll look at in Schoology, they're going to be integer answers, meaning no decimals, no fractional parts to them. But as we explore solving problems in chapter 7, decimals are okay to get as a solution, right? And we'll be working with fractions along the way as well. So it's not just going to be integer solutions that we look at. We'll have some decimal answers in there as well. All right, so one-step equations. So if we look here, meaning it's only going to take me one step to solve this problem. And again, working with integers, you might be able to look at the problem and see what you need to do without actually solving it, and that's fine. All right, but you still need to know the steps to solve for the problems. You can't just see the answer. So here's my variable, right? And I'm trying to isolate that, meaning get this by itself. So I have this number plus 7 equals 3, right? So the inverse of adding 7 would be subtracting 7 from both sides. Right, so that cancels. I'm left with x on this side. 3 minus 7 would give me negative 4. So my answer is x equals negative 4. Now remember, you can always check this by taking your solution and plugging it in for x, right? So ask yourself, does negative 4 plus 7 equal 3, right? And it does, so that is my solution. Number 2, here's my variable. So it's this number, and then this, there's not a sign out in front, but I know that that's understood to be a positive 2, right? I know that if there's not a number in front of the variable, it's understood to be a 1, right? So we have these understandings of those values, even though they're not written. So to inverse a positive 2, I have to subtract 2 from both sides, right? Positive 2 minus 2 cancels. I'm left with my variable n. 21 minus 2 equals 19. Right? And a lot of you might have been able to look at that and say 2 plus what equals 21? Well, I know 2 plus 19 equals 21. So that must be the solution. Right, here's my variable. It's on the other side. That's fine. We'll isolate it over here. So I have this minus 4. The inverse of subtracting 4 is adding 4. Right, so I'd get v, right, because that cancels. Negative 3 plus 4 is 1. So when I write my answer, you'll see that I just flip it around, right? An equal sign means it's the same on both. So if you want to start that problem and say v minus 4 equals negative 3, you can flip-flop sides because they're equal, right? They're balanced. It's the same on both. It doesn't matter which one comes first. All right, so my variable j right here, this is a minus 3, right? They put that sign there, so the inverse would be adding 3. Cancels there. I'm left with j. That is going to be equal to negative 5. All right, a couple more one-step equations using multiplication and division to solve. So here, this 3x, right, that is implied 3 times x equals negative 60, right? So 3 times something equals negative 60, right? And we should know that it's negative 20. But to solve it, I use division, right? Because 3 over 3 is 1, right? So that would leave me with my 1x. And I don't have to write the 1. It's understood to be there. But I have to divide both sides by the 3. And we get x equals negative 20. Here, right, this is 2 times b. So I'm going to divide both sides by 2, right? That would leave me with 1b. And that's going to be equal to 45 divided by 2, right? And here's not a nice clean answer, right? It's going to end up being a decimal. So when I divide 45 by 2, I get 22.5 for b. Here, this is supposed to be t divided by 2 equals 12, right? And the inverse of division is multiplication, right? Meaning I need to get that 2 up on the top here, right? So this would cancel, and I'm left with t equals 24, right? And you can always check these out, right? 24 divided by 2 equals 12. Here, this is negative y divided by 7. Okay, negative y divided by 7. So really, this probably should be in a 2-step because you're going to see it's going to take me 2 steps to solve this. The opposite of, and I could do it in 1. That's why it's in the 1 section. I'll talk about both. But a lot of you say, okay, this is divide by 7, so I'm going to times both sides by 7. So here, that would leave me with negative 1y. Over here, get that out of here. 7 times negative 5 is negative 35. Now, I want it to be positive y, right? This is negative 1y. So I can divide that by a negative 1. I can multiply it by a negative 1, right? All that does is it switches my answer to a positive 35. So let me back up real quick and show you how this can be a one-step equation. So this is really, it doesn't matter where the negative goes. It could be down here with the negative 7. So if I did this, negative 7, right? Well, the 7s cancel here. And a negative changes, right, to positive. When you multiply two negatives, it's actually a positive. So that would leave me with y. And then over here, I have to times by negative 7. Negative times negative would be positive 35. So that's how we could do that in one step. All right, moving on to the 2-step equations. Okay, 2-step equations, meaning it's not just one operation with the variable, it is multiple operations. So right here is my variable. I'm going to try to isolate this variable. And I have negative 4 times m plus 5 equals negative 15. So the first thing I want to do is get rid of this or inverse this positive 5. So I'm going to do that by subtracting 5 to both sides. So 5 and negative 5 cancel. That leaves me with negative 4m. And over here that would be negative 20. Now, this is negative 4 times m. So the inverse of that is division. Right? That will cancel out to be positive 1m. Here, negative 20 divided by negative 4 is positive 5. Right? And again, you can always check your answer by plugging it in. Right? So I'm going to plug in a 5. Negative 4 times 5 is negative 20, plus 5 is negative 15, so that checks out as my solution. So here is my variable. It's negative 8 times n, and I have this minus 7 over here, this constant, this number that doesn't change. So the first thing I want to do is get rid of that by the opposite, right, which is positive 7. So here that cancels. I would have 8n left over. 33 plus 7 is 40. Right? So 8 times what is 40? We can figure that out by dividing both sides by 8. 40 divided by 8 is 5. So again, 5 as the solution. Just coincidental there. And number 3, right? Here's my variable term. It's a number divided by 2 minus 10. So first thing I want to do is inverse this number, which I do that through addition. So negative 10 and positive 10 canceled. I get n divided by 2 equals negative 6 plus 10 is 4. So the inverse of division, I'd have to times both sides by 2. So that cancels me out there. I have 1n. 2 times 4 equals 8. So there's my solutions to the 2 steps. All right. And then we also had simplify and then solve, right? Meaning if I look at my equations here, I have 2 variable terms on the left side, right? Just my number on the right. So if they're the same term, right, 3x and 5x will give me 8x, right? So I want to simplify that first. Now I want to solve. So I have 8 times x equals 24. So 8 times what is 24? You can figure that out by division. So that would leave me with 1x. 24 divided by 8 is 3. Number 2, right? So I have 2x minus 3 plus 5. So my like terms are minus 3 and plus 5. So if I combine those, right, negative 3, positive 5, that's going to be plus 2. Oop, not 18, that's equal to 10. Right, I didn't do anything on that side. So now I have to solve for x. So here's my variable term. I want to get rid of or inverse this positive 2. So I start by subtracting 2. Here I'd have 2x. That would cancel. Over here I would have 8. And then if I divide both sides by 2, we get x equals 4. All right, so here 15 equals 3x plus 1 plus 4x. So on this right side of my equation, I have these like terms, these variable terms, right? I have 3x and 4x. That would give me 7x. I also have this positive 1 over there, and there's just the 15 here. So variable term, right? Think for a minute, what should we do with this positive 1? Subtract it. 15 minus 1 is 14. Over here we would have, I keep that division going there, so we have 7x, 1 and negative 1 is 0. So 7 times what is 14? Figure that out through division. So we're left with 1x here. 14 divided by 7 equals 2. All right. So those are just review of the problems that we learned how to do way back in chapter 3. All right. So what I'd like you to do for your assignment today is go to Schoology and work on the 7.0 quick check. All right. If you have any questions, let me know, and we will talk to you soon.